Oliver Bulleid's leader class of steam locomotive must be one of the most novel to have ever operated on Britain's railways. First steamed in 1949, the class was extremely short-lived, only one ever operated, and all was scrapped in 1951. One of the earliest models produced by Newman Miniatures was the leader class. However, with advancements in 3D printing technology and growing experience with designing CAD models, the locomotive has been subject to a heavy upgrade and improvement, with research ranging from photographs and documentation all the way to the original blueprints for the prototype. The result is a model super detailed, as accurate as possible to the original machine. This model has two different ways of being built. So if you are looking for the simple build, using the chassis unmodified, so having everything accurate but with unser-scale wheels, you need to stop this video and you need to look at the video which is listed in the link below. That's the one for construction. If, however, you are looking for the slightly more complicated extra chassis modification version, which replaces the wheels on the as-bought chassis with specific Bulleid-Firth-Brown BFB scale wheels, then keep watching. This video will explain the entire construction process. The first thing of the greatest importance are getting the correct components. Now, some of these, such as the chassis, are detailed on the individual sales pages, and you can get all the information there for all the extra parts needed to complete the locomotive. However, the 3D printed parts also vary depending on which version you're building. For the BFB version, with the scale wheels as detailed in this video, you need the main leader body, that's the same for both, but then you need the BFB version of the cabs and ash pans, the BFB bogies, and two of the BFB wheel packs. Now, the reason I'm emphasizing this is because those specific parts are not interchangeable between the two different versions. I'm stating it here. The information is also listed on every single sales page to ensure clarity. So ultimately, caveat auditor, caveat lector, caveat emptor, you have been informed, so do be careful to make sure that you are getting the correct parts for the correct version you intend to build. The body shell itself requires just the usual work associated with 3D prints, so that's cleaning up the print, priming, painting, etc. Now, there is the option, if you want, to add the piece of pipework here that has locating holes already in place, although I would stress it's important to make sure that the underside is flush so it doesn't impede on the bogie. Purely speaking as a customer, the decals are from Railtech and I think look rather effective. There's a link in the description below. So we have two sides and the end plates. So here we have the main parts for the cab interiors and the central ash pan. Now, they're designed with slots which are specific to each individual one, so they can only fit in one way when looking at the body shell. So if I bring that in just as a comparison, you can clearly see the two there which match with the two on that side. There are various bits which can be done to these just to add a little bit more detail. So for example, if I bring out the smoke box one, you'll see that there is an added reverser lever and similarly a smoke box dart. More important, however, is adding weight to these. So there is a recess in the back which has been filled with as much lead as possible. An equal amount has been added inside this one. When it comes to weight inside the central one, leave for the time being because we will be coming to that one towards the completion of the model. These are then ready to be painted. Avoid putting paint onto these areas because you don't want them to be impacted by any limitations with turning of the bogies. Conversely, there is one other extra detail to add because, as you can see, the modified version comes with a crew. Now you get several figures, so you can put them in both ends if you want, but if you want to be historically accurate, Leader ever increasingly only worked bunker first. They even actually turned her on turntables to avoid using the smoke box end because of heat. So for accuracy, this is the end which usually had the driver in. Furthermore, the driver, to all intents and purposes, never ran the engine solo. There was always a second individual, which is the reason why we provide two people which are designed specifically to fit into that area, keeping the model as accurate as possible, right down to the number of people. Turning to the bogies, there's various bits of preparation for these. Now, firstly, the sprue with the buffers, which was here, has been cut out and the buffers have been glued in place. They're separate, so you can have metal ones if you prefer. Next, a small piece of weight has been added in this area here. It's narrower than here, so there's no issue of it impacting on the wheels. You want to try and get as much weight as possible in different areas, but equally you don't want to overstrain, so it's a case of a little testing and so on as you go on. There is the space for a bit of extra detail, so as you can see here, I've added some brake material. Now, frankly, this is probably wiser to add later on after the chassis has been fitted. This is a learning curve here. I will warn, however, these parts are, as they stand, very fragile. Their main structural integrity will be once the chassis has been put in place. That and this central area here give it the strength. Until then, it is rather weak, especially around these areas here. Turning it again, we then have the bogie supports. As you can see, one fitted here, and we have the second one here. Now, these are a very close fit. Do not push them all the way without some gentle checking beforehand. All of these, as I say, are somewhat fragile to one degree or another, but I really mean it here. This one I tried, it went wrong, is a simple answer, so do be careful. What I would recommend, firstly, you can use a blade to score around just to make sure that this area here is clean of any support material. You can equally use a square file to file out that hole a little bit, but what I would recommend preferably, rather than attacking the model which is fragile, is amending these parts themselves, so paring down every face until you get a nice decent fit, which is tight but without it being too tight, without it risking the plastic. You can always add a little bit of glue later. So in traditional form, here's one I made earlier. I should also add, when it comes to the supports, that they are handed. They go in a specific way. So for example, the one which I showed just a moment ago goes in the front one only. The other one is bespoke to there. I should also say that when these are slotted into the body, there is a very slight gap between the lower and the upper. Obviously, I'm just holding here for demonstration purposes. There's a twofold reasoning for this. Firstly, the wheels are actually slightly taller than the frames, so you want to ensure that there is enough clearance between the body and the wheels. It's the same reason why the cab floors are actually raised slightly and the driver therefore has shorter legs. Secondly, one of the things which then accentuates the issue is that the tops of the frames, tops of the frames are flat, whereas the bottom of the body is angled, which makes it seem larger here than it actually is. Now, the big difference between the simple build version of Leader and this one are the wheels. Now, this is one of the wheels from the chassis as bought. And if I compare that to the correct scale BFB or Bulleid-Firth-Brown wheels that Leader had, you can see there's quite a marked difference. So this version of the kit comes with an alternate so you can make your own. The first task is to take the 3D insert, give it a very light coat of black paint. This is not only easier for the painting but also has a practical use later. And then drill out the centre. I've used a 1mm drill bit. It largely depends on the type of wire you're using for the axle, but again you want it to be as close to 1mm as possible. The next stage consists of fitting the tyre. Now, as you can see, I've got bought tyres. All the parts required for Leader are listed on the sales pages, so all the details of what to get are provided. Fitting the tyres is easier than it might sound. It's a case of placing it in gently, face to face, so you need to make sure that the flange is at the very top, and then using pliers, very gently pressing your way around the edge, ensuring that it's kept level at all points. That is how this one has been done, as you can see. One other thing which I found is quite useful is that when you're doing it, firstly go around like so, but when you've done that, to then start gently putting a little bit of pressure at an angle, very slightly, because you don't want to damage the rim or the wheel insert, but it helps lever it in that little bit more. Once that's done, I personally put the edges in a small modeller's vise, very gently pushing just that little bit further with even pressure, little bit working around in stages. Once that's done, the next stage, and this is where the painting has come in useful, is to ensure that the back of the wheel is entirely flush. This helps with fitting the pickups later. And so quite literally, I take a file, take the wheel set and do some light sanding. And as said, this is where the paint is useful because you can see where you've taken off and what are the raised and flat areas. Now I'll pause that there because this one has already been done. And as you can probably see, a small piece of wire has been fitted in as the stub axle. This is about 4mm long through the wheel, tiny bit of glue holding it in place, and that creates your replacement wheel set. I should also note that exactly the same technique is done for the unpowered wheel set, simply a case of slotting them on both sides like so. With the wheels complete, we turn to the chassis itself, and what we're effectively building is this, as you can see with the new wheels fitted in place. I've cheated slightly, this chassis has already been partly dismantled. So the first part is to remove the motor itself. You undo the clips on either side here and here, the central clip pulls off, and that gives you the motor part in itself, which can be put on the side. The keeper plate underneath, which holds the wheels and gears in place, looks like that. You simply unclip two ends and the two sides and it pulls out, which at that point gives you this, obviously with the two wheel sets, which look like this. We'll come to that in a moment. Once you've got the two wheel sets removed, for safety's sake it's probably best to put the keeper plate back on so you don't lose these two loose gears there. I should also note that the pickups, the original ones, once the motor's out, they simply click out of place, so again, very easy for dismantling. Turning to the wheel set specifically, you can clearly see you've got two metal wheels slotted into a plastic stub axle. And it's very easy. All you need to do, it's probably difficult to see for the video, but it simply pops out like so. You need to be a bit careful, but nonetheless it can unplug. Once you've unplugged both of them, it's simply a case of taking the new wheel set and slotting it straight in. So it will look like this. Once you've got this built, it's quite useful to keep the other one intact to put next to it just to check that the back-to-back is the same. And tiny bit of glue, do a bit of free rolling just to make sure that it is nice and level with no major wobbling. Once both wheel sets are in, you can then fit the new keeper plate, specially designed for this model. You'll see I haven't painted the underneath, the inside of it, just to ensure that the paint doesn't impact on any tolerances. The rest, however, is painted, and it clips in just like the previous one at the ends and the sides. It might be easier to pull out these very slightly just to ensure they go over the clips, and thereafter it just is a simple push fit. You push them back into place. Don't reattach the motor yet. This then gives you your complete rolling chassis. So with the keeper plate in place, as you can see, the next job is to put a tiny bit of oil on the gears and manually run it along a piece of track just to make sure that everything is freely running and rolling. As you can see, sticking to the track, but not sticking as far as the gears are concerned. A small but key stage at this point is one tiny modification to the motor housing itself. Now this is designed so that it is in essence a reversible process. You can easily remove these wheels and the keeper plate and put the original items back on. The one thing which is permanent but doesn't prevent the mechanical regression if necessary is to very lightly file off a slight bit of a corner on each side here. As you see, if you're careful, it doesn't affect the pickups at all, but it gives just that extra little bit of clearance for the flange. Once that's done, temporarily reattach the motor. Just a case of clicking in those two and pushing in that, and then using some batteries, just do a quick little motor test to make sure that everything is fine with the motor. So if I do this in a way so that you can see, as you can see, everything is turning over reasonably happily. Naturally, there's going to be some running in required once the model is finished. Now we come to the one active bit of scratch building required for the project, making the pickups. You can see the diagram has the main dimensions on it, and basically if you use thin brass to cut a rectangle 20mm by 8mm, you then cut that shape out at the bottom. Now it's more accurate on the diagram than this test one, and cut 2 lines down here. You then fold down the 2 tops on either side to make it double thickness. Again, you can see that it's effectively about 1.5mm down. You cut a little bit beyond that and bend them inwards, as you can see here, and then these 2 wings you fold inwards as well in the same direction. These then slot around the keeper plate side behind the wheels, as you can see here. You want it to be at roughly that sort of height. Now the keeper plate holds it in place, and fitting the motor on top attaches it with contact to the strips underneath. Once that's done, you want to do a thorough bit of testing. So in the case of the one which is here, you can see, whoops, a little bit on the fast side. You can see that it runs reasonably well even without any weight. Now obviously you want to do some decent testing. I will equally note that because of course this is a relatively short wheelbase, it's advisable once you've done this to take these out and solder a lead from one to the other, so that gives you the widest possible wheelbase with electrical pickup. I should equally say that for ease, the ashpan print has a recess in the top of it which the wires can go through, just to make it a little bit easier for you. Now the chassis are complete, we turn to fitting them into the bogies themselves. Firstly, we start with the unpowered wheel set, which like others in the range, is just a case of dropping it into place and holding in place with a couple of strips of styrene. Next, we then go back to the chassis themselves, dismantle the motor, the pickup, so you've just got the rolling chassis, and slot it into place. Now, the brake gear here is a little in the way, so in fairness, it's probably best to be fitting that only after this stage rather than earlier, as I did. It might be a little bit tight here, so do be careful, don't force it. If you need to take off a little bit of fettling will help, but it again should slot straight into place. And here's one done earlier. Once you've got it in, you can put it on a piece of track, make sure that everything is straight and level, just tweak it to suit and balance properly. Then it's a case of fitting the coupling. Now there is a little pilot hole in case you want to pin one in. Conversely, you can glue an NEM pocket like this one straight in place. Equally, at this point, it's good to bring in a bit of track, bring in a test vehicle, and just line everything up, just to make sure that the couplings do work. Lastly for this stage, there is an optional extra, because on the motions part you'll notice this little piece here. This is the end of the frames, and it's quite prototypical for the engine, but the benefit is because of the gap, prototypical, you can fit it around an NEM coupler. So you can either have it on its own, just using the little legs to glue it either side of the coupling support, if for example at the front end you don't want a coupling at all, or you can glue it in like this, and of course with an NEM coupling you can always remove the coupling, so having the best of both worlds. With this done, it's now a case of fitting the pickups and motors and doing one last check before we reach final assembly. However, the keen-eyed may have noticed that there are a few places which have not yet been painted. Naturally, of course, there's some cleaning up to doing in a few areas as well. And the reason is that during this final testing stage, a bit of extra weight is quite probably going to be necessary. So if I bring in the other chassis, you can see here that another little layer has been added here. It must be well below the height of this support here, so I'd suggest not higher than the flanges of the wheel. And you'll also see that a little stack has been put on top of each of the supports here. This means that it's not only directly weighing down the motor bogie itself, but also is not getting in the way of the clearances as the bogie turns. Pausing the construction chronology for just a moment, I know that some of you may be looking at this and thinking, oh, making new wheels, that's rather difficult. I've never done that before. Well, full disclosure, full honesty. Until I was making this model, and indeed this video, I'd never done this either. You at least have the advantage of knowing that the parts work. I didn't, so it was a case of development, trial and error to get something which I know is accurate for when you purchase the parts. Also, another small point which I previously was not aware of, no doubt some of you certainly will be, is that the connection wire between the bogies that I recommended needs to be a thin, flexible wire, the likes used for DCC, locomotive pickups. I was not aware of this and used ordinary wire, which worked in theory, but once assembled the locomotive for test, proved to be far too stiff and prevented the bogies from turning. So I'm saying this so you're aware to use the correct thing, but also you will notice a bit of continuity issue as we carry on, where the wire seems to change a little bit from one section to another. I'll also note the fact that in an attempt to make the incorrect wire work before having identified the issue, I cut away large sections of the ash pan point. Now, again, this is not actually necessary. This was an error on my part, but it does, however, demonstrate that as long as you keep the sides and the uppermost sections of the edges intact, you can actually cut away quite a lot of the ash pan if you need to for any reason without compromising the part. So, having said that, back to the construction. With everything painted and prepared, we now turn to the main assembly. The first thing to do is to take the smokebox end cab and glue it into place, as you can see here, and to put together some weight to put inside the ash pan unit in the middle. Now, The rest of this, and including that bit of weight, at this stage, don't glue it in, because in the case of the weight, you're going to have to do some initial running trials to identify the optimum amount to include. Too little, you won't have enough traction. Too much, you might strain the motors. So it's a case of doing a bit of a gentle balance. Similarly, because of course you're going to need to add or remove weight, initially the ash pan and the bunker you don't want to glue in, so you can then reverse this step to get them out for testing. It's only when you're absolutely happy with everything that you finally tack glue them in place. So the easiest way to assemble all this, making sure you've got the bogies the correct way round, is firstly to put the ash pan the correct way round in between the two bogies like so. Make sure the wires aren't caught up. Slightly more fiddly. There we go. Then you take the body, slot the wires inside, and get the front in roughly like so. Flip it over. Oops. And make sure that the ash pan is locked in place. There we go. Which means that the bogie supports in each side are between the curved sections. This bogie can then be moved back a bit to connect in with that side. It's very difficult to actually show on camera, so apologies if this is not the clearest visually. Then take the bunker cab, angle this up, slot in, gently find the locating point and push in place. Then carefully roll back round again, because of course at this particular moment it's not glued together, and you'll see that the model is now in one piece. Through a rather handy little thing, the piece of pipework here very slightly clips in underneath, so holding the ash pan loosely in place during this testing stage. Now from this point we head on to actual testing itself, fine-tuning, and once complete, reverse that, add a little glue and reassemble to get what you see here. With testing, you might find some slight sideways play of the bogies. So to counter that, you can add some strips, as you see here, of 1mm thick styrene. These are added centrally to the motor, that is between the wheel sets of the motor chassis, just to reduce that while still allowing them to turn on curves. Turning towards the end of the build, you'll notice on each buffer beam there are 3 holes. These are for the brake and steam heat pipes. Now, Leader had different arrangements at different points, so do look at your prototype for what livery and arrangement you want. I will note that the central hole, the one which is the highest up, that pipe actually trailed downwards and it can interfere with the coupling. So if you want that at just the front end, the hole is there. Conversely, the other 2 pipes go upwards, and therefore as long as they're lower than the height of the body, there's no impact with the operation of the engine. Once this is done, then one turns to the obligatory coaling, and at that stage the model is complete. And so we have it, Bulleid's Leader in N-gauge, super detailed. This was, of course, an experimental locomotive, though, and had various modifications throughout its short life. So, regarding whichever livery you wish to paint it in, always look at prototype images to see about any changes. A single example, as originally built, which is how the model has been designed to replicate, the valve gear at each end actually had an oil bath cover. Those have been deliberately left off because they're easy to make with just a small piece of curved styrene, and instead give the full detail for those who want slightly later on with this original livery, and of course the subsequent liveries that the locomotive operated in. To close, I hope that this video has been of use in explaining the techniques for constructing this particular model. Leader was certainly an unusual engine, something interesting to add to any British Railways era fleet, and I hope that this has been of interest. Thank you for watching.